Hello everyone, welcome to my channel, Packet Palette. Firstly, I want to briefly introduce myself. My name is Michael Ivan and I'm a network and security engineer. To open up this channel, I hope to share my daily work knowledge and cases. And also, this is a very good experience for myself to improve and gain more knowledge. So if you have any thoughts or any advice, please comment. Okay, cool. Let's kick it off. Today I want to talk about the FortiGate high availability. FortiGate is a very popular firewall in recent years because it's easy to use and maintenance. It's cost-friendly for small business. Meanwhile, HA is a very important feature for a firewall cluster, but if you want to deliver a good design, you need to think of several points before you start. So today I will go through the basic concept of HA first and then introduce several places you need to think of when you design a management network for the FortiGate cluster. And last, I will go through all this detail in my lab. So what is HA and why we need it? As we know, disaster recovery is always an important topic in network design, especially for some important customer like bank and the government. 1 second outage maybe means $1 million loss. So a firewall cluster can help us to solve this problem. And normally we will put 2 or more devices into a firewall cluster. So even if 1 or more device got failed in this process, and all the service traffic can still spill over to other available nodes. And from the customer perspective, they won't note a change or any outage in the network. To build this kind of firewall cluster, we need to meet several requirements first. For example, if we want to build a firewall cluster with 2 firewall nodes, then these 2 nodes need to be exactly the same module and the same firmware version. And at the same time, we also need to consider about the licensing, hardware drive configuration, and operating mode. All these criteria we need to meet here is just to make sure when a failover happens, all the service can successfully transfer from the one node to another without causing any outage. These 2 firewall can either be 2 physical firewall or 2 virtual firewall. Then next, we need to prepare the configuration of the cluster. Here at the bottom right of the slide, you can see the example configuration of the cluster. First, we need to confirm the operation mode of the cluster. Usually, we have 2 options here. One is active and another is active standby. To my experience, we will use active standby more often, which is at the same time only one device will processing the traffic. Sometimes we will also use the active mode, especially when we have the VDOM enabled and we have limited through output resource for the firewall cluster. So we will maybe use half of the VDOM as the first firewall as primary, while the rest we use the second firewall as the primary. That's about the firewall operation mode. And the next thing we need to confirm is the group ID. As we know, when a firewall cluster is formed, it will broadcast the virtual MAC address to the whole network. And the group ID here is just to use to generate that virtual MAC address. So when you allocate a group ID, especially in a data center environment, you need to make sure that group ID is unique. Otherwise, it may cause some strange issue and which is not very easy to troubleshoot. The next 2 things is the group name and the password. The group name which will make the cluster or the configuration easy to recognize, and the password will provide some additional security for the cluster. And the last thing here is the heartbeat port, which the 2 nodes will use the heartbeat port to communicate with each other and monitoring the status, and then decide whether it's time to do the failover. There's one configuration didn't appear here, which is the priority. The priority will decide which node will become the primary node and which will become the secondary node. So it's also a very important configuration, especially when you're trying to do the failover. You need to follow some kind of the logic and then know what's the result of your operation that will minimize the downtime of the whole firewall cluster. Slide, I will going to show you how the primary FortiGate is elected and you will know how the primary will influence the final result. Similarly, we have two scenarios here. On the left side is the first scenario, which we have the override disabled under the system HA configuration, and this is the default configuration of the FortiGate. By sequence, the two nodes will compare the available ports, HA uptime, priority, and serial number. Always the one with the great number will become the primary node. One thing we need to notice here is that about the HA uptime. If the difference of the HA uptime between the two nodes is greater than 5 minutes, then the one with the greater HA uptime will become the primary node, and the two nodes won't no longer compare the priority and the serial number. But if the difference is less than 5 minutes, then that means the two nodes will skip the HA uptime comparison and then compare the priority of the two nodes, and the one with the greater priority will become the primary. And on the right side is another scenario which we have the override enabled. So the only difference compared with the left side is that the two nodes will always compare the priority first, and then if the priority is the same, and then it will compare the HA uptime. I think we will use the configuration on the left side because it provides us a cooldown time when a failover is happened. If we use the configuration on the right hand, and when a primary node with higher priority just enter a zombie or half-dead status, it will cause the whole cluster failover again and again. This is not very good for the whole service, so we prefer use the default configuration. Pretty much all the basic stuff I want to talk about the HA cluster. The next I want to talk about some design details about the management network for a firewall cluster. The first thing is about the management IP of the firewall cluster, because in our daily work, especially when we're trying to troubleshoot an issue, it will be more convenient if we can log in the web GUI of the two nodes at the same time. Although the FortiOS has provided us some command just to jumping from the one node to another node through the command line, but the web GUI is still more convenient. So to make it happen, we need some additional configuration, because as we know, all the configuration within the cluster will be shared between the two nodes. So what we need to do here is under the system HA, we need to enable the HA management status and then specify the dedicated management port for each node, and then specify the gateway of that management subnet. By doing this, we will able to log in to the two firewall nodes separately at the same time. Thing worth to mention is about the monitoring of the SNMP configuration of the firewall cluster. It's also necessary to monitoring the both node of the firewall cluster, even if the standby node is just waiting and didn't process any traffic. I can give you an example here. Think of you have a firewall cluster and it has two firewall nodes. Firewall A is the primary and the firewall B is the secondary, and you're only monitoring the active node of the cluster. If the firewall AA just hit some bug and it's into the console mode, so all the traffic will automatically fail over to firewall B. But from the monitoring system perspective, everything will still looks good because firewall B is all healthy. But if in some situation, the firewall B hit the same bug and it's also into the console mode, you have nothing to fail over. You will lose your backup. So if you monitoring the both node, you will find the issue necessary and maybe just arrange a single reboot will solve the issue. Configuration is also very simple. Just on the basis of the left side configuration, you just need to enable the HA-Direct under the SNMP user. Then you will be able to parse the status of the both firewall from your SNMP server. So that's all about the boring theory part. So next I will show you some details in my lab. So apart from the auto configuration that I have talked about earlier, I will also want to show you the upgrade process of the firewall cluster, because it is also a very normal operation in our BAU's support. And the topology here is also quite simple. I have two virtual firewall nodes and form a firewall cluster, which is running in the active standby mode. The cluster just connected with two networks, the LAN side and the WAN side. I also have a dedicated management network. And the only service we need to test here is the connectivity from the LAN test host to the WAN test host. As I can show you here, it's available, so everything is working fine. And first thing I want to show you is about the dedicated management IP. So from here you can see that I can log into the both node firewall A and firewall B separately, because I have enabled the HA management status under the system HA configuration, and I specify the port 8 is the dedicated management port, and the gateway is 1.245. And then the next thing I want to show you is about the HA-Direct configuration. As I mentioned earlier, if you want to parse the SNMP configuration separately from each node, you'll need to have two things configured. The first thing is that we need to enable the HA management status, which we already done here. So another thing is that we need to configure the HA-Direct under the SNMP user, which I already enabled here. So now we can just try to grab the information from each node. Here we will use the SNMP work command on our management test host. So the target is firewall A, and we will try to grab the host name here. You can see here it's a success, and we can also grab information from the firewall B, and also success. So yeah, if you want to grab the CPU usage, memory usage, and also the port status, you can use just some similar command on your SNMP server. But now if you try from the LAN jump host and grab the same information from the shared IP address, let's see what will happen. For example, our shared IP address is 101.0.0.1, and I can show you that I have already kind of put the IP address of the test host in the whitelist. So in theory, it should work. But after you try, you will find it's no response from this shared IP. So that's also an impact of that HA-Direct command. As long as you enable it, you can only grab the SNMP information, use that dedicated management IP. But if you parse the information from this shared IP, there will no response. Okay, then let's come to our last part, which is the HA cluster upgrade. Before I start, we can just have a check the HA status here currently. So we can see the firewall B is the primary and the firewall A is the standby. Even though the firewall B have a lower priority, but because it has a greater uptime, it's become the primary node. We can see after we do the upgrade, what will happen. And one more thing to mention before the upgrade is that in our daily work, before we do the upgrade, I think the best thing we need to do is that we need to do a reboot on the both side of the cluster, because in some situation, the both node of the cluster maybe hasn't been reboot or upgrade for very long time. For example, 1 year. If you just go to the upgrade directly, it's very likely the firewall node will hit some bug or due to some strange issue, it won't boot up. So that will put yourself in a not very good situation. So my recommendation is that before you do the upgrade, especially when uptime is quite long, always reboot the two node first and then do the upgrade. Usually we have two methods to do the upgrade. First, if you have the FortiManager deployed, you can use the FortiManager to do the upgrade. So it will automatically calculate the upgrade path. You just need to choose the target version, and the FortiManager will do all the things for you. And another way is just do it manually by logging to the FortiGate web GUI. So when you do the upgrade, remember always log into the primary node, upload the firmware image, and do the upgrade. Also, please do check through this upgrade path too, and just to make sure what is the intermediate version you need to go through and prepare all the firmware image. Okay, that's all we need to do. Let's kick it off. So the firewall B is the primary, and we can start to upload the firmware image. The target version will be 6.4.14. We will just do the backup and start to upload the configuration, and we can choose the file just to choose a folder just to store the configuration file. Okay, so the upload here is almost finished. And what it will be do next is that the image will upload it to the firewall B, and the firewall B will transfer the image to the standby node, which is firewall A, and then firewall A will upgrade first, and then it's the firewall B. So we can have a look at the on the console. So yeah, the image has been uploaded successfully to firewall B, and on the firewall B, we can see that it's sending the image to the secondary node and then wait for the secondary node to be upgraded. And if we go to the firewall A, we can see that the image check is okay and it's waiting for the system to restart. So the firewall A is doing the upgrade right now. Let's be patient. So yeah, in this process, the firewall B is just keep on monitoring the status of the firewall A through the heartbeat port. Okay, we can see the firewall A is booted up right now, and if we go back to firewall B, uh, we should be able to see that its monitored status changed. Yeah, so the failover will happen, and all the traffic will be failover to the firewall A, and the meantime, we can try to do the pin, and we can see the pin is still going well. That means that during this upgrade process, the service won't be impacted. And now if we log in to the firewall, we can see what's the status of it. And now we can see the version is 6.4.14 right now. And yeah, we can see the firewall B is also up and running, and the cluster is synchronized. So it depends on the size of the configuration file. It may take some time for the two nodes to synchronize with each other. For my scenario, because as I mentioned earlier, the configuration file is quite small, so the synchronize is happening really quick. And what we can see here that the firewall A is currently the primary node. Uh, and what we can do is that we can just try to reboot and the firewall A, and we will see who will become the primary node. It will take some time. Yeah, so firewall A is up and running now. From what we can see after the reboot, firewall A is just still the primary. So even if the firewall B has the bigger uptime, the firewall A is just still the primary node. And currently, I think we have the override uh, disabled. Yeah, that's what I have said, that if the difference of the uptime between the two nodes is less than 5 minutes, uh, it will just still compare the what is the greater priority of the two nodes, and the one with the greater priority will always be the primary node. Cool, that's all I want to talk about today. And then I will share all the reference link in my PowerPoint to the description area of the video. And if you have any question, please leave me a message. See you next time.